Happy New Year! We've all seen some amazing flashing Christmas lights this year, but what do they have in common with your beeping alarm clock? Well, they're both based on timer circuits. There are many different ways, but an easy one to start with is the 555. No, I don't mean fives from the Clone Wars.
I don't want to end up a wall decoration.
I mean this chip. So I've got my 555 timer here, and I'm going to connect it in a way called astable mode, which means that it oscillates between two states. I connected pin 1 to ground, and then between pin 2 and 1 I added a 1 microfarad capacitor, then connected pin 2 to pin 6. I then connected two resistors, a 470k resistor between pin 6 and 7, and then a 1k resistor between pin 7 and pin 8, then connected pin 4 to pin 8. I then got ready to add my LED on pin 3, but first I added a protective resistor and then connected the LED to it. Now be careful of the LED's orientation here, because the long leg on the LED is the positive end, and that is connected to the resistor on pin 3. And the other shorter leg is the negative side of the LED, which I'm going to connect straight to ground. And my final step, connecting my pin 8 to the positive rail, which I'm connecting to my 9-volt battery. Now that I've built my circuit, I want you to see what happens when I change the capacitor. As you can see, with different capacitor values, the frequency of the light flashing changes. When I connect the oscilloscope, I can visualize those frequencies and get many more measurements, like the duty cycle, for example. Duty cycle is the ratio describing how long the LED is on or off for. When I change the resistors on pins 6, 7, 8, then I can control how long the light stays on or off for individually. If you want to have a go to build your own timer circuit, I've put links to all of my components and equipment on my Design Spark article. And I'll see you in another episode of ShroukieTronix, the Shrookie show about electronics. Thank you, bye, ma salama.
There's nothing she can't do.